In this video, we're going to look at the basics of volume. And a couple main ideas that I want you to think about as we're going through this are fill and faces. Fill, I think, is a little bit more intuitive. Most often when you hear problems related to volume, it's how much water can you fill a particular vase with, or a cup with, or a fish tank with. Those are common contexts. And I'll explain a little bit later in the video what I'm talking about with faces. But before we get into that, let's just recall two-dimensional area first, because that's ultimately the building block that we need before we get into volume. So just remember, when we're dealing with area, what we're really asking is how many square units of some particular size. It could be inches, it could be feet, it could be yards, it could be miles, it could be whatever length we're talking about. We're asking how many square units can I fit inside some particular shape, right? So for this example, we had a backyard and we wanted to know how many stone slabs would it require to fill the entire backyard. And you notice even with problems like this, right, that the edges here are curved. It's not perfectly rectangular, so we'd have to factor that in to find the area. But you get the basic idea, right, that we're using square units to find two-dimensional area. We're saying how many squares can I fit inside of this shape. So now when we extend that to 3 dimensions, we're not using squares anymore, square units, we're using cubic units. So recall the fish tank that you saw above, and now instead of squares, we're saying how many cubes can I fit inside, right? And recall that up here, the squares could be stacked on top of each other, right? In front of each other, behind each other, and to the left or to the right of each other, right? Well, now here when we're working in 3 dimensions, the cubes can be stacked in multiple directions here. So we can do on the side here, we can do them in front, and we can stack them now in a 3rd dimension as well, so we can stack them up. And the basic question still applies, right? How many cubic units, whatever it is, if it's a fish tank, maybe cubic inches, cubic feet of water would fit inside that tank, okay? And so this is not just, this particular visual is not to do an example with, but just to help you have the visual that you need to understand better what we're talking about, right? The idea of stacking cubes is really what goes into volume, which I think is most often what's used to illustrate these ideas. So then what about these faces? I think it's helpful when we're thinking about the extending of a particular face, right, a two-dimensional face, and we stretch it. And I'll show you some examples of what I mean. So if I take this rectangle, right, and I extend it into the 3rd dimension, right, so now it has a depth, right? You can think about I just took that face, right? I took however many faces, and I stacked them on top of each other, right? And I extend it. So now I've given this two-dimensional face some depth. So I've taken this two-dimensional object, I've brought it into the 3rd dimension, okay? That's really what we're talking about, is we have all these cross sections that we've stacked on top of each other, these multiple copies of the same face, and we've brought it into 3 dimensions. Okay, so when I'm talking about faces, this is the idea. So if you find that helpful, I think that's something helpful to think about, at least for me, right? As we have these, and you can reverse the process too, right? So I can go backwards. But the idea again is just you're taking some known area of some two-dimensional face and you're stretching into the 3rd dimension. And so you see ultimately then that all you need to find, once you know the area, right, of any of these faces, right, let's say you know the area of this octagon, all you need to find then is how long this now extended figure, this new 3-dimensional object is, right? That would be the height or the depth or whatever they wanted to call it. And so you just multiply whatever the area of the face is by that height. And like we were talking about up here, remember that when you find that, you would use cubic, right? So you would say feet cubed instead of feet squared, right? Or you could write it out as cubic feet, like that, okay? And we'll go through some examples in just a minute, but again, I just want to show it one more time. Oops, sorry. Show it one more time, the idea that you can extend these faces as far as you need to go, okay? So that's something helpful to maybe think about when you're working with these problems. So we have fill, right? We're filling up some three-dimensional space with water or whatever we're working with. But you can also think about it like extending faces. Okay. And before that, a quick word from our sponsor. And our sponsor today is Steamboat Mickey, wearing a pair of Jordan 4s, playing a little basketball at his local rec. And why is he our sponsor? He's our sponsor because Steamboat Mickey is public domain now, and I felt like it. So enjoy this nice little image of Mickey. All right, thank you, Mickey. Now a couple quick examples. Again, so instead of when we had normal area, it was base times height, or length times width, whatever terminology you want to use. And now all we're doing is we're adding another dimension to that problem. So volume is not the multiplication of two things, but rather the multiplication of three things. So instead of just length times width, now it's length times width times height. If you're already using the word height, maybe they use depth, right? So it would be base times height times depth. Because again, you can think about the object, how deep it goes into the board, how deep it goes into space. Okay? So let's work through a couple together real quick. So if I have this rectangular prism, I'm told it has a base of 12, a height of 5, and a depth or a length of 7. All I have to do is multiply all those numbers together. So 12 times 5 is 60. Okay, so 12 times 5 is 60. And if I was just finding the area of this face, that would be 60 inches squared. And I'd be done. But again, now we're taking this face and we're extending it, right? We're extending it out 7 inches in depth. So now I take that 60 square inches and I multiply it by 7 inches. Excuse me, 60 inches squared, right? This face, and I'm multiplying it by the depth of 7 inches. So it makes sense also why this is going to become cubic inches, because if you think about it, inches times inches is inches squared. Inches times inches is inches squared times inches would be inches cubed. 60 times 7 is 420. So the volume of this rectangular prism would be 40 cubic inches. Excuse me, 420 cubic inches. Okay, last example. Same process applies. Find the area of the face and then see how deep it extends. So we're told the radius is 2 centimeters, and we're told the depth of this cylinder is 15 centimeters. So first let's find the face. All we're given is the radius, but that's all you need to find the area of a circle. So let me just move this down a little bit. Okay. So recall that the area of a circle is pi r squared. We're given r, okay, so we just have pi times 2 squared, or 4 pi. Okay, and again, that would be centimeters squared. And now we're going to multiply that by the 15 centimeters up here, right? Again, that's our depth. That's how deep this cylinder goes into the screen. Okay, so we have our area, 4 pi centimeters squared times the depth, 15 centimeters. That's 4 times 15, which is 60. We put our pi on there, so we have 60 pi centimeters cubed. Okay, or cubic centimeters. Okay, so hopefully those examples were helpful. Again, just one last time. Hi, Mickey. I think if it's helpful to you, great. Extending the faces out, right? Think about it as you find the area of that initial face, right? And then you're just seeing how deep does it extend out. That's the idea. And again, obviously thinking about it as filling up some object with a certain amount of water or liquid or whatever. Okay. So hopefully these examples were helpful to you. Thank you for watching, and I'll see you in the next video.